In this module, we will be talking about polynomials and various things about these polynomials. So first of all, let's define exactly what a polynomial is. A polynomial is a set of terms containing variables and coefficients for which the only powers are positive integers. Some examples of polynomials are y equals 3x squared minus 7x plus 12, or y equals 4x to the fifth minus 8x to the third plus 7x minus 9. The zeros of a polynomial are what makes the polynomial equal to 0. We're being asked to find the zeros of the polynomials. And the first one we are given is y equals x squared minus 3x minus 4. We need to set this equal to 0 and factor it if we can. This factors into x minus 4 times x plus 1. Set each factor equal to 0. And we get zeros for this polynomial of x equals 4 and x equals negative 1. On this example, we have y equals x squared plus 8x minus 33. We're going to start by setting it equal to 0 and then factoring if we can. This factors into x plus 11 times x minus 3. Set each factor equal to 0 and solve. We get x equals negative 11 and x equals 3. On this example, we have y equals negative 4x times the quantity x squared minus 36 times the quantity x minus 7. We need to note that that first quantity of x squared minus 36 is a difference of squares. So the first thing that we have to do is factor that into x minus 6 times x plus 6. And then we'll leave everything else exactly as it was. Now we set it equal to 0. And then set each of these factors equal to 0 to find the zeros of the polynomial. Take a look at what's on the very front, negative 4x. You have to determine whether you should use this or not. If there is a variable, you use that item. So we do have one factor of negative 4x equals 0. A second one of x minus 6 equals 0. A third of x plus 6 equals 0. And the last of x minus 7 equals 0. Well, to solve this first item, divide by negative 4, and you wind up with x equals 0. You get x equals 6 from the second, you get x equals negative 6 from the third, and you get x equals 7 from the fourth. Note that we got 4 zeros this time, and that will happen sometimes. On our next example, we have y equals 5 times the quantity x minus 5 times the quantity of x plus 5 that's being squared times the quantity of x squared minus 4. So what you need to recognize about this one, the first two items are both just to the first power. But that second quantity of x plus 5 being squared means that we actually have x plus 5 twice. The last quantity of x squared minus 4 is a difference of squares and factors into x plus 2 times x minus 2. So setting all of this equal to 0 to find our zeros, Now we need to take a look at what we need to use for each of our little equations. On the very front this time, we have a constant of 5. There is no variable. Because there is no variable, we ignore that. If you think about what we are doing, we are taking the factors and setting them equal to 0. And it doesn't make sense to say 5 equals 0. That's a false statement. So we ignore the constant of 5. We set our first quantity of x minus 5 equal to 0. We next have the quantity of x plus 5 appearing twice. We do not need to write it down as an equation twice. So we are just going to write one time x plus 5 equals 0. Then we have x plus 2 equals 0, and x minus 2 equals 0. So the zeros of this polynomial will be x equals 5, x equals negative 5, x equals negative 2, and x equals 2. On this one, we have y equals 2 times the quantity x minus 9 times the quantity x squared plus 25 times the quantity of x plus 7 being squared. When we do our rewrite, just to look at what we've got, the first two items are to the first power. We're going to leave them alone. This quantity of x squared plus 25, it does not factor because it is a sum of squares, not a difference of squares. So we leave it as x squared plus 25. The last item, the quantity squared, means that we would have x plus 7 times x plus 7 written twice. So now when we think about setting this equal to 0, we still have this same equation. And we have to decide what we're going to use as smaller equations of the factors that we have. Remember, we have a plain constant on the front. When you have a plain constant with no variable, you ignore it when you're writing small equations equal to 0. X minus 9 we will set equal to 0. X squared plus 25. I'm going to write it down here just to show you what happens. And then x plus 7, we do not need to write it twice. We're only going to write it one time because it's the same thing twice. So on this first quantity, x minus 9 equals 0, we get a 0 of 9. If you were going to solve this quantity of x squared plus 25, the first thing you would have to do is subtract and get x squared equals negative 25. There is nothing that you can square and get an answer of a negative. So this yields no zeros. We ignore that item. And then from our last little equation, we get a 0 of negative 7. Our next definition is multiplicity. And the multiplicity of a 0 that says x equals c is the number of times that the factor appears in a fully factored form of the polynomial. This is equal to the exponent of that factor. We are going to find the zeros and the multiplicity of each 0 for our polynomial functions. So I'm just going to set up a little table here where we have the 0 in one column and the multiplicity in the second column. This polynomial is already fully factored. So when we look at the first item of 7x cubed, we would use that to find a 0 because there is a variable there. What 0 would that give us? That always gives us a 0 of 0. What's the power on that variable? It's a 3, so the multiplicity is 3. Next, our first quantity gives us a 0 of 13. What's the power on that quantity? It's 1, so its multiplicity is 1. Our next quantity, x plus 2 quantity squared, would give us a 0 of negative 2. What's the power on it? 2. So the multiplicity is 2. And then our last quantity of x minus 2 to the 4th gives us a 0 of positive 2, and the power on it is 4, so its multiplicity is 4. On this example, we have another polynomial that's already in factored form. So we're just going to set up our table. And start looking at it. Our first item is the 9x squared. That gives us a 0 of 0, and because it's power 2, the multiplicity is 2. Our second quantity of x minus 7 squared gives us a 0 of 7, power is 2, so multiplicity is 2. And then that last quantity gives us a 0 of negative 13, and since the power is 3, multiplicity is 3. Before we start our next example, I want you to remember to find x-intercepts, you set the equation equal to 0, and to find y-intercepts, you put in 0 for x. So your instructions will tell you to find all the x and y-intercepts for the graph of the function. And the function that we are given is 3x to the third plus 3x squared minus 18x. So the first thing that we are going to do is find our x-intercepts by setting the equation equal to 0. I'm going to start by putting in 0 for y, or f of x, and then I want to take note that 3 and x divides each of those terms. If I take 3x out of 3x to the third, I'm left with x squared. Plus, take 3x out of 3x squared, you're left with x, and take 3x and divide it into negative 18x, you're going to get negative 6. What was left on this equation after we pulled out the 3x factors into x plus 3 times x minus 2. So for our x-intercepts, we're going to set those factors of 3x equal to 0, x plus 3 equals 0, and x minus 2 equals 0. On our first little equation, divide both sides by 3, you get x equals 0. Subtract 3, you get x equals negative 3 on the second, and then on the third, add 2, you get x equals 2. Remember that x-intercepts are points. So you write your x value, and then the y value is always 0 on the x-intercept. For our second x-intercept, the x value is negative 3, y value is 0. For the third, x value is 2, y value is 0. To find y-intercepts, this is easier because we take our original equation. I'm just taking out f of x and replacing it with y, and we put in 0 anywhere we had an x. So on our first term, we would have 3 times 0 to the third. Second term, we would have plus 3 times 0 squared. And then last term, we would have minus 18 times 0. Well, that just gives us 0 plus 0 minus 0, which equals 0. So our y-intercept always has an x value of 0, and in this case, our y value was also 0. On this function, we have f of x equals x cubed minus 4x squared minus 25x plus 100. And to find the x-intercepts, we want to set the whole equation equal to 0. So something that's going to help us is going back a little ways. We haven't done this for a while, and recognizing we have 4 terms, and we're going to split that in half. So on those first 2 terms, what's in common is x squared. If I take x squared and divide it into the x cubed divided by x squared leaves us with x. Take negative 4x squared divided by x squared, we get minus 4. Looking at the second pair of terms, we're going to take out a negative 25. 25 goes into both 25 and 100. Negative 25x divided by negative 25 leaves me with positive x, and 100 divided by negative 25 leaves me with negative 4. So now we have matching quantities, and we're going to have x minus 4 that we pull out, and if we take x minus 4 out of this entire first term, what's left is x squared. Take it out of this entire second term, what's left is the minus 25. Now, x squared minus 25 is a difference of squares. So that factors into x plus 5 times x minus 5. Each of those factors needs to be set equal to 0. From the first factor, we get x equals 4. From the second, we get x equals negative 5. And from the third, we get x equals positive 5. So our x-intercepts, the x value gets written first, y value is always 0. X value of negative 5, y value of 0. X value of positive 5, y value of 0. So this function has 3 x-intercepts. For the y-intercepts, we put 0 in for x. So we'll have y equals 0 to the third minus 4 times 0 squared minus 25 times 0 plus 100. So we get 0 minus 0 minus 0 plus 100, which gives us a final answer of 100 for our y value. So our y-intercept for this function has all y-intercepts have x of 0, and the y value is 100.